Today is Friday the 12th, and we're doing alcohols, naming, hydrogen bonding. Water. Hello out there. Say hello if you're with me. It's Noah. Good morning, Noah. Hope you're doing well in this snowy, crazy at-home learning time. And there's some more. Good morning, Sarah and Lily. Thank you for being there. Nicholas, good morning. Marla, good morning. Natalie and Deacon, good morning. And a bunch of folks. Julian L., Dominic, Lee. And Vincent. And Julian K. This is a good question. Lily, maybe you can ask me a more exact question about that assignment, and then I'll come back to you. And I need to know, I got Priya, I need to know who Baby Bell is. Larissa and Shilpa and Tadashi, hello. Okay, I think I got everybody so far. So Lily has a question, I think, about the assignment that I gave you, or the one that I have not given you yet. That's my question. I want to give you one on, actually I gave you a review assignment, I think. So I don't really, it's from last year, it's review, so you should ask me questions about this. Isabella, thank you, Isabella, that's fine. Just need to know who you are. Thank you, ma'am. Okay, so for Lily and anyone else, if you have a specific question on the review assignment that I gave you, why don't you ask me that specifically? Which number, and I don't have it with me, so you can tell me what the problem was, okay? So try and type something in if you have a question. I'm happy to help you out on it. It's to review concepts from 9th grade Chem. I know some of you have not had that, so I sent a video about naming alkanes and line and structural formulas and condensed formulas. So if that was new to you, there we go. I think the short answer, Lily, is no. The homework I gave you was to review naming and drawing alkanes. The video had more to do with line drawings and condensed formulas, but those are not in the assignment that I gave you. So if you have a question on the assignment I gave you, you should ask me during the hour today. Okay, let's see who else I got. Noah wants 2C. Very good, Noah. Can you type in what 2C is, Noah, while I check a couple others in? Okay, Riley is here. Thank you, Riley. And I'm seeing from Noah, an error occurred in naming the following alkane. What is the proper name? 2-ethylpropane. Thank you, Noah. 2-ethylpropane. Good. We'll look at that in just a moment. We'll look at that in just a moment. Just want to see if I get anybody else. It'll take about 1 more minute. If you're here, Magdalena, let me know. Also, Aiden K. and Lena, Tom, Christian, and Ali. Everybody else I got, which is good. Ah, Tom is here. Good. Thank you, Tom. Anybody else out there before we start up? If not, I'll put this aside and take Noah's good question. Maybe others had the same one. Here we go. Let's try and draw it. So propane is how many C's, folks? Propane is how many C's? Ah, Magdalena's here. Thank you, ma'am. I knew you'd be there. Okay, good. How many C's in propane? Thank you, Tom, Noah, Lily. There's 3. So 1, 2, 3. Good. At 2, I've got an ethyl branch. How long is an ethyl branch? Oh, everybody knew that one. Thank you, everybody. Good. Wow, great participation. How many C's long is an ethyl branch coming off of number 2? And it's rolling again. You guys are good. Okay, so Larissa and others got it as well. So it's 2. So here we go. Boom, boom. All right, now, here's the problem. I'm not going to put in the H's yet because I want to show you something. This is two-dimensional. It looks like a T. It doesn't look like that in real life. In real life, these things can rotate around. They're not breaking up, but watch this. What if I rotate this up? Then I've got this. 1, 2, 3, 4. And I've got to see this one coming off the second. Do you see already what the problem with this name is? It's not 2-ethyl propane. You have to name it for the longest parent chain. The longest parent chain is not 3. How long is the longest parent chain? And can somebody tell me what the parent chain name is? And I'll put in the hydrogens now. What's the parent chain? What's the name for that parent chain? In other words, this name does not exist. It's not correct. Okay, super. Thank you, Shilpa and others. Great. So it's a butane. And Shilpa and Larissa and some others have already put the full name. And I've got a methyl group. And I want to count not from the longest, but from the shortest side. So I'm going to say that's 2-methyl butane. Thanks, everybody, including Noah yourself, for participating. Questions about that? Or any others you want to ask about on the assignment? Now's your chance. While you think about it, I think I'm going to erase this, at least the first part, because I think we already have that down. Anything else you want to ask about with the assignment before we start up with our new topic today, our new 10th grade topic? Pri has a question. Okay, how you went from 3 to 4? Easily. Watch this, Priya. If I move this thing down, and can it do that in 3 dimensions? You betcha. Fold it down. Fold this C down. And then it looks like it's 3 C's. But it's the longest chain is what you want to go by. So really, I don't want to fold it down. I want to leave this C up at the top to show that it's the longest chain. Before it looked like this, and that just is not possible. It's not a chain of 3. It's a chain of 1, 2, 3. Or if you want, Pri, I can fold this one up. And it's still the same name, 2-methyl butane. So the problem we have, Priya, is 2-dimensionally it looks possible. 3D, I cannot draw that. I've got to make the name for the longest chain, parent chain that I've got, the long chain name. You're welcome. Let's see if I got another question. Yeah, it is. Magdalena asks, Can you do the answers on another sheet? Go ahead. You can do it on a sheet of paper if you want. Take a picture of it and upload that picture into Google Classroom. All right? I'm okay if you do that. That's fine. You don't have to try and do it on a Google document because these are time consuming to draw on a Google document. How do you know that you would bring up 1C? Lily, from experience, frankly, you know it because if I can do it, I will do it. So I've got to look, and I know this is new for some of you. I've got to look and see where the longest chain is. Is it 3? No, it's 4. I can go either this way or that way. That one can swing up. The longest chain is not 3, it's 4. So why not put it at the end to show that it's 4 in the chain? And there's a couple others like that in the homework as well that I'm trying to get tricky, but you look for the longest chain to name the alkane, okay? Here, I'll give you one more. Check this out. All right. If you didn't know what you were doing, you would say, oh, that's 2-ethyl. No, 3. 3-ethyl propane. But it's not. It's not at all, of course. What is this? If I could fold something up, so let me ask like Priya now, if I could fold something up, I can make this into what? What is it really? It's not a type of propane. That is like wrong. What is it actually? Good. Natalie's got it. And Priya, let's see if you've typed it in as well. So what does it fold up to be? Good. Several of you have it. Sarah has it there. Thank you, Priya. Okay, so it is just pentane. And I can say N-pentane for fun. N means normal, which means like in a straight line. So it's just N-pentane. Okay? It's not any sort of branch. In general, I cannot put branches on the first or last C because they just become part of the main chain. I can only put branches on middle carbons. Okay? Comprende? Any other questions from you? I think that'll help you finish up that assignment. When's it due? Like Tuesday or Wednesday? I think I gave you enough time to do it. Or is it due this afternoon? I've given so many assignments this week, I don't remember. But I hope that gives you enough time and information to complete it. It's due Tuesday, so you got time. Thank you, everybody. So I hope that'll work for you. Yeah. For the first example, all right, Shilpa says there were 2 carbons at the end. That's right. So what that means, Shilpa, is that I've got a branch here, but I don't have 2 branches. One of these, and it doesn't matter which one, can swing up to show the world that the molecule is really a straight chain of 4. And one of them remains a branch. So if I've got some sort of T shape like this, I can make some giant T. Of course there's going to be a branch. But you know what? Don't get silly about it. Okay? Here, I'll make this even longer. I've got to look for the longest chain. I'm not going to put the H's on here so I can show you. Oh, the longest chain is not 1, 2, 3, 4, 5, 6. It's 1, 2, 3, 4, 5, 6, 7. The longest chain is actually that. And I can draw it out. And then I'm going to redraw the whole thing and have the branch of 2, an ethyl branch, coming off of 1, 2, 3, 4, the 4th carbon. So you can't move both, right? That's right. And you don't want to move both. One of them is going to be a branch because that's what a T shape does. Okay? One side's a branch, the other side's part of the main chain. But one of them will move and become just a straight molecule. We'll build some of these in class, I hope, when I get you as a live bunch of people with some models, and we'll try and show you. In fact, even if I draw it straight, it's not really even straight, it's more zigzag. But we'll show you that together at some point. Good. Any other questions from you before we do something new? Doesn't matter which side you move. Yes, Lily, it does. You want to get the longest chain. Like, look at this. 1, 2, 3, 4, 5, 6. Well, do I want this one here? No, I want the one up here. That's going to make it 1, 2, 3, 4, 5, 6, 7. I want alkanes are named for the longest parent chain possible. So this would be 7 and not 6. So if I redrew it, let's just do it instead of talking about it. If I redrew it, it would be 1, 2, 3, 4, 7. 1, 2, 3, 4, 5, 6, 7. And then this thing will be off what? 1, 2, 3, 4, or the other way, 1, 2, 3, 4. Well, that's easy. And I'm going to put it down below. It doesn't matter which side I put it on. So that becomes this. So I get from something that looks sort of silly to something that looks more like a standard way we would draw the structural formula for an alkane. And then that I could name, or any of you could name, but we don't have to do that. Good. Any other questions before we continue? It's good that you're asking, because I'm going to assume that things are crystal clear and that you had regular 9th grade organic chemistry, or you're busy trying to catch up if you came from somewhere else. And I know a couple of you did. So please ask me questions. And if you're really lost, write me a question on the class stream or an email, and I will get back to you at some point. Okay? All right. Then let's get to our goal for today. Here we go. We want to talk about, how do I want to say this? No, I'm just going to begin. And we'll come back to the, okay, so let's talk about alcohols. In German, alkanol. Okay? In case you get it in German next year. A lot of the words are really similar in organic in English and German, okay? Okay, I got a question here. Let's see. Okay, no, you cannot have a methyl branch on the last. It's just part of the main chain. I'm not allowed to have any branches on the first or last. Like, look at this. No, that's not a branch, because that sucker is always just going to swing up and become this. So I don't have any branches on the last or the first carbon. You just don't. You just don't. I could have it on a second carbon. Okay, so the rest of your question I don't quite understand, so I hope that answers it. Okay, so alkanols have a O or an OH attached to the, generally it's an alkane. Let's do an example. By the way, the OH is called a hydroxide, but we're going to think of it like a branch, you and I. And as a branch, just like in naming alkanes, as a branch, we're going to say it's a hydroxyl. And now we're not going to say branch either. We're going to say hydroxyl group. I've got a hydroxyl group on it. It's an alcohol. All right, Magdalena says, can you have branches branching from other branches? Yes, but it's extremely rare and we won't cover it in this course because it's not very important, even biochemically. But thanks for asking. Okay, so let's do an example. Let's do a really simple one. So here we go. Here's 1C with an OH. Now, you remember how water is bent? Remember that from last year? So is the OH, and that's really important. It's not straight going out there. It's bent. It has to do with bonding electrons, which you'll study more in grades 11 or 12. So I can't really tell you why, but it's bent just like water is. Okay? All right, add some H's. Okay, that's got one bond, so the carbon needs 1, 2, 3 H's. So the formula here would be CH3, and then we write OH after that. Why? Because the OH is special. I knew I could write CH4O, but most people don't. Now let's name this sucker, okay? 1C would be what? 1C would be what alkane parent chain name? One C would be what alkane parent chain name? Don't ask me to say that 10 times. Thank you very much. Good. Noah, Lily, Shilpa, Larissa. It's methyl. So what we do is we're going to write it as methanol. So in chemistry, an OL ending is what we use for alcohols. With an OL ending, okay? That's the symbol for an alcohol group, as it were, or a hydroxyl group. It's got an OL ending. Okay, so methanol. Or, ready? Here's the old-fashioned name, but you might see it on one of my handouts at some point. So I'll give you the old-fashioned name. So the old name would be methyl alcohol. Yeah, that's spelled right. So it's two words. And in German, by the way, it's the same word, methanol, just capitalized. Good. Dominic knew that too, and Riley. Thanks, everybody. Lee, thanks for participating. Okay, so far so good. I just lost my marker. I hate it when it happens, and it happens all the time. It's what I get for having a 1 square meter office here, or studio. Let's do some more alcohols. Here we go. By the way, methanol is called wood alcohol. If I can ferment wood, and only some insects can do that, like termites, I get methanol. So a termite, you'd find in a termite some methanol, okay, wood alcohol. It's not drinkable. It's rather poisonous. Okay, let's do this one. Give me a name for that one. Magdalena asks, why does the OH has to be bent? I'll give you the straight answer, Magdalena, because in a p orbital, the electrons cannot be across from each other. It's two different p orbitals. Now, a p orbital is something you'll study in 11th and 12th grade. So the answer I'm giving you doesn't make sense. So you can't really grasp it. I know that. So you're going to have to take it from me. The sucker's bent. You'll find out later why. Same with water. Water is also bent, which we'll talk about later today. Good, I got several of you had an answer already, and most of you are right. For example, Tadashi has it. It's ethanol. Some of you know this way too well. This is the one that's in beer and wine. And other spirits, as we say. So, yeah, that's ethanol. Okay, I don't want you to get bored. Let me jump to something more interesting. Okay, let's make, well, let's just go to the next one, but it is more interesting. Here we go. So the next one, let's do it like this. This is, no, you might as well give the name somebody. So if you got three, oops, need another H, sorry. If I got three C's, it's going to be what name? Go ahead and punch it in. I'm glad some of you have these memorized, or at least you have your data table nearby so you can start to memorize them. That's cool. Thank you, Tom, and others. It's propanol. Now, the deal is for propanol, here's the problem. The OH could be at 1 or 2, couldn't it? So, gang, this is called 1, this is called 2-propanol. Why? Because it's at carbon number 2. 1, 2, 3. You know what I'm saying? Okay. If I drew 1-propanol, and by the way, 1-propanol would be the same as 3-propanol, wouldn't it? So we just go by the lowest number possible. So 1-propanol going to be like this. Whoop, whoop, whoop. And I'll just put it out here. It doesn't really matter where I put it, as long as it's bent. Shaboom, 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 shaboom. Got the H's on it. Voila. So there's your 1-propanol. Now here's the deal, gang. You might say, well, whoop-de-doo, who cares? They do have different chemical qualities. So these two, for example, would have different boiling points. Just having the OH at a different spot matters. So the location of the OH affects boiling temperature. You know how water boils at 100 degrees? Well, these probably boil at 2 different boiling temperatures because the OH, the hydroxyl branch, is at a different spot for each one. We call that the boiling point. Affects boiling points and other stuff too, but probably the most important thing is attractions to other molecules. Okay, and I think with that, we're going to jump to our next item today. Let's see if you have any questions so far. What decided where the OH goes? Nature, or I decided because I wrote it on the board. It can go in different spots, and there's probably also biochemical reasons that it's in one place or another, depending on the reaction, Magdalena. But I don't need you to know those biochemical reasons until you take organic chemistry at university in your second year. There's probably reasons where the OH, why the OH is at a certain number. But for you and I, we don't need to know that. Do you have to write the 1? Yes, when it's possible, you could have other things. Like I don't need to write 1 ethanol. Why not? How many possibilities are there? 1. It could either be at 1 or over here it would still be really at 1. So 1 ethanol I don't need to write. But Noah, once it gets so I can put the OH at different spots, I need to tell somebody which one I got. And if I order it in my lab, I need to write if I'm ordering 1 or 2 propanol. So they are different chemicals. Weird, huh? Slightly different. See if I got other questions. Yeah, Lily, it's about counting the C's. So we just start at one end and start counting the C's. That's carbon 1, 2, 3. Oh, my hydroxyl branch is off of 2. So that's 2. That's not part of the name. 2 propanol. The OH, the hydroxyl branch, is off of 2. Down here, it's off of 1. Do you have to know that? No, I'm going to give you that. You have to name it. Or if I give you the name, you have to draw it. Should we do a drawing? Here, let's do a drawing. Ready, everybody? Let's draw the structural formula. I'll abbreviate that for 2-pentanol. Everybody sketch that, and then I'll ask you a question. No, Tadashi, 1 propanol is 1 propanol. Because I could have 1 or 2 propanol, Tadashi, I got to tell somebody what I want. Do I want the stuff that has the hydroxyl branch on the first C or the second C? I can order either chemical. So I don't want to just say propanol because I can order 2 different ones. And it might matter with my experiment or my product or whatever I'm doing with it. That's right. I wouldn't say 1 ethanol, right, Magdalena, because 1 ethanol, I don't need a 1 there. There's only 1 possibility. 1 isomer, if you remember that word. Here, there's more than 1 isomer. There's 2 isomers. I can have 1 or 2 propanol. Remember, isomers, they're the same structural form, same molecular formula, but different structural formula. So propanol has 2 isomers. Maybe we should say it that way, huh? You like that? Propanol has 2 isomers, 2 ways to draw it, 2 structures that are possible. A 1 propanol or 2 propanol. Okay, let's go back to the one I asked you for here. Draw the structural formula for 2-pentanol. Good. How many C's do I got here? What's my parent chain? Parent chain for this, somebody? Yes, we'll come back to that, Noah. What's my parent chain for this sucker? Thank you. Good. Thank you. Okay, so pentane. So 5. 5 C's. 1, 2, 3, 4, 5. Good. 2-pentanol means I've got an OH on where? How about Vincent? Where's my OH going to be here? I know it takes a while when I ask you to. So let's see if I get from Vincent. Vincent, where's the OH going to be? Where's the hydroxyl group going to be? No, not on the third one. It's on the second one, right? So 2, it's on 2. 1, 2. OH. That's 2-pentanol. 3-pentanol would have a different boiling temperature. Okay. 1 pentanol would have a different boiling temperature. And then that's it. If I put it over at 4, that's the same as 2 pentanol, right? If I put it at 5, that would be the same as 1 pentanol. So I don't have an unlimited number of places to put the OH. Here I got 1, 2, 3 different places. Could I have more than one OH? Yes, and we will have this in the class. We can talk about that in a second, but I want to see if there's any other questions you have first. And there are. Good question. Shilpa asked if it matters which side I put the OH on. Do a little mental experiment. You ready? Take this off the board. Ready? Turn it like this. And the OH is at the top. Does it matter where I put it? Answer starts with an N. No. Okay, so it doesn't matter whether you put it on top or bottom. I don't care. But it's got to be on the second C if it's 2 pentanol. All right, any other questions? How would it be the same? It would not be the same, Lily. It would be a difference. Like if I moved it here, that would be different. That would be 1 propanol. If I moved it here, it would be 3 propanol. But if I move it here, wait a minute. Ah, come on, that's still 2 propanol, isn't it? Now I can start from this side. Carbon 1, carbon 2, up. So I could draw my 2 propanol like this. Nobody does, but you could, because that's also 1, 2, the second spot. You always go from the lowest number, okay? The lowest number of C's from whatever side that is. So I could draw 2 propanol this way if I wanted to be funny. Good. Other questions from you before we continue? They're good questions. Just to give you a heads up to where we're going, alcohols are one of the main functional groups that deal with not only like alcoholic drinks, but they deal with a lot of chemistry in the human body. So your body uses alcohols to make other things that we use all the time, okay? Even including like fats and stuff like that, which we'll get to later in the course. So alcohols are like a basic building block we need to know about. And they're based on what? An alkane plus an OH group. Yeah, so you can count from the left or right, whichever gives you, Lily, the smallest number. So that would be 1, 2, and that's what we wanted. Okay? All right. Let's do this one. 2, 3. Hexadiol. Okay, now I'm throwing you a curve. I'm throwing you something new. The di here is right before OL, so it means I've got 2 hydroxides. Means 2 hydroxyl groups, or hydroxyl, there's an O in there, 2 hydroxyl branches. Okay, sometimes I say groups, sometimes I say branches, it doesn't really matter much. So let's go for it, okay? So I got hexadiol. So hexa, 6, I bet you know that. 1, 2, 3, 4, 5, 6. And I've got OL, aha, it's an alcohol. Where are they? I've got 2 of them. Di, well, they're at 2 and 3. And if you want to put another dash, you can. I don't really care. It doesn't really matter much. So there's one at 2, an OH. Let's put the next one up above. Does it matter? No. They move like this, right? This can move down or up. This can move down or up. These are 3-dimensional molecules that I'm drawing on a 2-dimensional blackboard. So you've got to kind of imagine that they can move around on you a bit, okay? I could even bend this thing down here, but that would be stupid. Why show that? Why not just draw it straight? It's more clear, right? Okay, so hexa is 1, 2, 3, 4, 5, 6. I've got hydroxyl groups, 2 of them. Di means 2. Remember, tri meant 3. And they're at 2 and 3. And the rest I'm going to fill in with hydrogens until every C has 4 bonds. Ta-da! So we could call this a dialcohol if you want. A dialcohol. Could there be a trialcohol? Yeah, there could be. Yeah, so far so good. So if you have 2 or more OHs, hydroxyl groups, the prefix goes right before the OL, which makes sense because that's what indicates that it's got a hydroxyl group anyway, right? Okay, let's see if you got other questions I can answer now. Yep, got that one. What would be called if there was a double or triple bond? That would be called an 11th or 12th grade question. So, Shilpa, I'm not going to give you one that's an alkene or an alkyne that has hydroxyl groups. Do they exist? Yes. Are they common? Probably not all that common. When we get to fats, we might discover something like that, but I'm going to wait till then, okay? Generally, we're not going to have a lot of double or triple bonds. And really, Shilpa, in nature, I don't know of a lot of reactions that have that. I'm not an expert on organic chemistry, but I don't think it's real common to have like a hexadiol-ine or some awful name, okay? So you're not going to need to worry about that. It could occur, but I don't think it's common. Good. Any other questions from you about naming stuff? It's good to get those squared away. It's our first day with alcohol. Do we do it in AP Chem? No. Ironically, when I teach AP chemistry, folks, it's all inorganic. None of it is organic chemistry. So strangely enough, all of what we learn in 10th grade is not covered in AP chemistry, except for some of the ideas, but not the molecules. What we're going to do probably next time now, but we'll start maybe today, is talk about the forces between molecules. That's an AP important quality. And one that I even give my 9th graders if I have time each year. This year's 9th grade, we did talking about intermolecular forces. So it's really important for all chemistry. But organic, I don't teach it in AP. It's not there. Good. All right. Scoopy-Doo. Here we go. I'd love to see lots of you in AP chemistry, by the way. I got a lot of good brains out there. I understand if you're doing the Abitur program, may want to do chem or physics in the Abitur. That'd be great too. Don't get me wrong, but I teach in the diploma program. I don't teach a Leistungs or Grundkurs. So then you're on your own with my German colleagues, or potentially Mr. Blessman sometimes does something like that. Okay, all right, let's continue on. Okay, I want to label this. No, I don't. I want to review something with you. Let's see if some of you had this word before, because we need it for the next topic. Electronegativity. Does that ring a bell with any of you? Here's what it is. It's the attraction of an atom to electrons, especially those in a bond. It may not matter so much in 10th grade, but especially the electrons in a bond. All right? if I take a periodic table, the most electronegative one is F. It's up in this corner, kind of. So as I get closer to F, I get increasing electronegativity as I get towards fluorine. Electroneg for short for now, okay? That's going to be important because it means F is an electron hog. It's all about hoggability. F hogs the electrons, and what it means is it pulls it away from somebody else. Why does that matter? Because F ends up having more negative charge and the other atom has more positive charge. And we're going to look at that next time. So let's stop right there, and I'll see you next week. And then we can start more with intermolecular forces. That's really a huge idea for all chemistry. Okay? I will not see you Monday because we have the actual day off. I got it right this time. And I will see you then later in the week. Okay? Stay healthy. Have a good weekend, all.